lines that go through circles. Now, it's not a chord, and it's not a diameter, and it's not a radius. They have a new, different name. So this is what you're going to add to your toolkit right off the bat. It's possible for a line, if you were to draw it with a circle, to not go through the circle at all, but that's not very exciting. It's possible that when you draw a circle and a line, that the line go through the circle in two distinct spots. That's going to be called a secant line, a line that intersects a circle in exactly two places. So all you got to do is draw yourself a circle-ish and draw some kind of line that goes through it. Now, it's not a segment, it's a line. So it's got to go completely through it, and it can keep going. So it's basically like an extended chord. Okay, so that line is your secant line. Now, it's also possible to have a line that only intersects the circle at exactly one point. That's called a tangent line. Now, you may remember the word tangent from when we did trigonometry in SOHCAHTOA. This tangent, while it looks the same, says the same, spells the same, is a different thing. All right, so it's not related to like the opposite over adjacent that we did back in trigonometry. So this tangent line looks something like, it doesn't really matter where you do it, but it only touches the circle in one spot. Oops, my line's a little wonky. There you go. Just one spot. That's it. It just kind of rests on the circle. Now, there's a very cool relationship between the tangent line and the diameter / radius that intersects it. If I draw in my radius, you can probably guess there's something special about this angle here. It makes a 90-degree angle. So the tangent is going to be perpendicular to the radius or diameter that meets it at its point of tangency. The point of tangency is going to be this thing right there. All right, so we have the tangent line, and we have the point of tangency, and then any radius or diameter that intersects at that exact point makes a 90-degree angle. There's a really cool proof for how you can prove that that's true, right? I'm really, you know me, I love proofs. I think they're great. So I'm going to link in your assignment to another video or two, because I found two that I really like. So take a look at those. It's not me, it's another teacher explaining it, but it's really cool. They talk about this way to prove, it's called an indirect proof or a proof by contradiction. Basically, you start by assuming that you're wrong or something else is true, and then you go through to prove that that thing is true, but then you realize that you made a mistake and it's impossible. So then what you originally believed has to be false. So I want you to go and watch those videos. So actually, yeah, press pause on this, go watch those videos, and then you can come back and kind of understand it better. So now we're going to use this fact right here to help us solve a couple problems. Okay, so we have to solve for the missing length. Assume that lines that appear to be tangent are tangent. So that means that every exterior line meeting with a radius or diameter forms a 90-degree angle. So what do you think we're going to be using? Pythagorean theorem. Yep. You can also, if you were given some other angle measurements, could maybe do trigonometry, right? Like use your SOHCAHTOA. So that might be an option. So I want to do what? I'll do, let's see. Let's start with number 3. Why not? So in our right triangle, this question mark is like our C side. That's our like a squared plus b squared is c squared. So if I set up my equation, 12 squared plus 16 squared equals c squared. So 144 plus 16 squared is 256 equals c squared. Add that to 144, I get 400 equals c squared. Remember, then you have to square root both sides. Square root of 400 is 20. So that's your missing part. Not too bad. Now, what if it's one of the legs? So let's look at number 2. 2 is a little trickier. So this one, it tells me that this part is 1.5. This part is 1. I'm trying to solve for this part. And I don't also know this part. However, this thing and this thing, they're both radii. So if this is 1.5, this is 1.5. So if I set up my Pythagorean theorem, let's call this x. You can call it a or b or whatever you want. So I have 1.5 squared plus x squared equals, this whole thing is 1.5 and 1. So this is going to be 2.5 equals 2.5 squared. So 1.5 squared is 2.25 plus x squared. 2.5 squared is 6.25. So take away 2.25 from each side. X squared equals, was that 4? Square root x equals 2. Nice. Press pause in this video and see if you can do 1 and 4. So hopefully you can see that we were trying to solve for a leg here, so we get 7.5. This one, if this part was 6, the other radius is 6, making the diameter 12, and that one's 13.6. Now, your assignment today is very short and simple. You simply need to answer this question. Okay, line PQ is tangent to the circle at point P. So point P is our point of tangency. If PQ is 5 and CQ is 6, we want to find the length of CP. And then you also have to find the measure of angle C. So you might need to use something else, maybe SOHCAHTOA. To submit your work today, it's going to be just an email, something short and simple. Just email me your work if you want to take a picture of it and email it to me, or if you just want to type out your work. I do want to see the work though. Don't just tell me like the number is 12 and the angle is 37.5. I don't know. Those are made up. And if they're right, I don't realize they are. So you can take a picture and send it to me on an email, or if you want to type it out and send it to me that way. My email is millerl@emhs.net. Now, the second page of this, I heard from some of you that you're wanting more, okay? Now, a lot of people said they want less. I can't do less. But what I can give you is more. These are just for fun, some challenge problems. There's a proof on here. There's some calculations involving tangents and things like that. So if you're up for a bit of a challenge, feel free to do those. I will at some point be posting an answer key, maybe in video form, but maybe more likely just written out so you can see the answers to those after you've tried them. Again, it's not part of your assignment. It's just something for fun, for extra. Now, we are kind of coming to the end of our circle unit. There's a lot on circles that we could have done, but we're just kind of doing little tidbits here and there. We're going to be having a quiz on circles probably next week sometime. We have to learn about equations of circles. And then, actually, no, the week after that, because we'll have a little bit of review. And then we'll take like a quiz test thing on circles. As always, you can use your toolkit, so make sure you're filling that out as we go through our lessons and kind of start reminding yourself about all of the things we've learned. If you're confused about anything, please reach out to me. I would love to help you understand, to help make this go a lot easier for you. So, hope you guys are doing well. Have a good weekend. Next time I'll talk to you is next week. See ya.